Hi, my name is Azura and I'll be explaining about Experiment 2 Activity 1. Let's go. So first we need ground, and then we take another ground, and then the third thing we need is the AC power. Put it in series with the ground, and then we take resistor, only one resistor. Rotate the resistor 90 degree and then connect to the ground. Connect the power also to the ground, and then we take the wattmeter. Connect the voltage probe in parallel with the resistor, and the current probe in series between the resistor and the voltage source. And then we need to change the voltage value to 100 and frequency 50 Hz. And then we change the resistor value to 210 and start the simulation. And then observe the power measured, 47.619 watt. Stop the simulation and then change the resistor value to 390. And then start simulation, and we observe the power again, 25.641 watt. Stop the simulation and then change the resistor to 470, and then start the simulation again, and we see the power 21.277 watt. Stop the simulation and then change the resistor value to 860 ohm. Start the simulation again, and then observe the power, which is 11.628 watt. Okay, after that we need to put another resistor in series with the first resistor. Okay, we need to buang balik connection yang pertama, and then we connect the resistor in series, connect to the ground, and then connect the wattmeter probe again. The voltage in parallel in series with the resistor, and the current probe in series with between the resistor and the voltage source. Alright, and then we change the resistor value to 110 and 470. I'm sorry. And then start the simulation and observe the power, which is 14.0760 watt. Start the simulation, and then we change the resistor value again, the second resistor value to 860, and then we start the simulation and observe the power, which is 9.346 watt. After that we need to put this resistor in parallel, delete the first connection so that we can change it to parallel. Add another ground for resistor 1, then connect the resistor in parallel. Change the resistor value to 110 and 470 and connect again the voltmeter probe, the current in series between the power source and the resistor, and the voltage is in parallel to the resistor. Alright, and then we run the simulation and observe the power, which is 68.896 watt for this combination. And then we change the resistor value to 860 ohm, and then we run the simulation again and observe the power, which is 59.247 watt. That's all for me. Thank you.
Hi, Assalamualaikum. I'm Zul. I'm gonna do to the activity 2, which is to measure the power in unit var, Q var, in AC circuit, which contain the resistor and an inductor. We arrange the component same like the circuit in the Labsheet. Starting for this activity, use the single phase var meter to measure the reactive power of circuit. We get the wattmeter. The current probe is series to the circuit, and the voltage probe is parallel to the circuit. We change the AC source properties. We change the amplitude to the VPK. VPK equal to square root 2 times VRMS. And we change the frequency to 50 Hz, same like the circuit in Labsheet. We change the resistor value to 210 ohm and inductor value to 0.4 H. We change the unit to var because we're gonna measure the reactive power, and we connect the ground to the circuit. Start simulate the first one. We get 20.9 var. Stop this simulation and change the inductor value to 0.8. We run the simulation and get 23.2 var. We change the inductor value to the 1H. Run the simulation and we get 21.8 var. We change the resistor value to 860 ohm. And the inductor value to the initial 0.4 H. We run the simulation and we get 1.65 var. We change the data value to 0.8 and we run the simulation and we get 3.12 var. And the last one, we change the last value of the inductor, which is 1H, 1.0, and we run the simulation and get 3.74 var. Thank you.
The component required in activity 3 is AC power source, resistor, and wattmeter. And lastly is capacitor. We take the capacitor and connect it into the circuit, just like the schematic diagram given in the lab sheet. Then we need to change the resistor value to 210 ohms. And the capacitor value, we need to change it to 2 micro. Then we can run the simulation, and this is the measurement value when the capacitor value is 2 micro. Then we need to change the capacitor value to 4 micro. Then we can run the simulation, and this is the measurement value. Next, we change the capacity value to 8 ohm, 8 micro. Then we can run the simulation, and this is the measurement value. Next, we need to shift the resistor value to 860 ohm. Then the capacitor value back to 2 micro. Then we can run the simulation, and this is the measurement value. Next, we need to change the capacitor value back to 4 micro. Okay. Then we can run the simulation, and this is the result. This is the result. Lastly, we need to change the capacitor value back to 8 micro ohm. And we can run the simulation, and this is the final answer, the final measurement value.